Buongiorno a tutti, mi chiamo Matthieu Napoli, ma non sono italiano, sono francese. I'm a software developer, software consultant. I also work with open source projects like phpday, Bref, which I will mention. I've worked on some PSRs in the PHP Fig PSR 11 and 15 and 17. And today I'm here to talk about serverless and PHP. If you do not know what serverless is, that's fine. That's what we are here to learn about. So the idea of the talk is to start with serverless in general and progressively move towards PHP. Have you heard about serverless before? Raise your hand just to get an idea. Okay. And have you used it, created something that is serverless? Okay, great. So you will maybe learn something. So what is serverless? The idea behind serverless is to change the way we run applications. Today, when we want to run an application, we think with resources. Resources are like servers, disk storage, and stuff like this. Like we have to buy resources or rent them and think about how to scale them, how to maintain them, and whether we have enough resources, whether we have enough servers, enough disk space to run the application. And moving from the traditional way of hosting applications to serverless is to move from resources to services. With a service, you don't really care how the job just gets done. And I have a few examples, maybe that will be more explicit. Storage as a service is a perfect example, I think. I'll get back on that example. We have today database as a service, caching as a service, authentication as a service. Maybe you've heard of Auth0, that's a good example. Search as a service, Algolia is a perfect example as well. With those services, you just pay and use the service, and again, it just works. The idea behind that is that you have to manage less things. Think about storage as a service. And especially Amazon S3 is a great example. With Amazon S3, you don't have to manage the disk space. You don't have to monitor it. You don't have to take care of redundancy. It's Amazon's job. You can scale more because, again, with Amazon S3, you don't have a limit. You don't buy 200 gigabytes of space. You just use S3 and send as many files as you want. And then again, it's Amazon's job to scale. And they are pretty good at it. And finally, you pay. That's not always the case, but it's usually pay per use. So you pay for what you actually use. Instead of paying for the 200 gigabytes of storage, you only pay for the few kilobytes you may be using. Those are sometimes true, sometimes they aren't, but this is the general idea, this is the theory. And there is one service that we are interested in as developers, and this is function as a service. To give you an example of what function as a service is, I will show you an example of Amazon Lambda and Lambda functions. Those are two examples, one in Python, one in JavaScript, and those are very basic Lambdas. As you can see, those are functions. In JavaScript, you have a callback because this is JavaScript, but anyway, a Lambda function takes an event, do whatever it wants, and then returns a result. That's what function as a service is. And that's interesting because we have an event. What is an event? An event can be an HTTP request. So we can take the HTTP request and return a response. An event can be a message in a message queue, like in a job queue. So we can process jobs asynchronously. It can be a cron, like every day at midnight, run this task. So the event would be something like, hey, this is midnight. And it can be actually many things in Amazon, but it's also true in Google Cloud and Microsoft's Cloud. You can have events for many things like, let's say, a file is uploaded to S3 and you have to process it. So let's talk about, more specifically about HTTP, because as PHP developers, that's what we often do. We write HTTP applications, web applications. And the way usually things run is a bit like this. You have an event, which is the green arrow, and it will trigger some code, and the code will return a response. But in reality, that's not how it works. It's more like this, where the large blue bar is the server. And the server is running all the time, and it's waiting for requests. So it can be Apache, Nginx, PHP, FPM, whatever. And the code that is actually executed when there's a request, finally, is our script, is our controller, is our whatever. Moving from traditional applications to serverless is moving from that to that, where we just care about the code that gets executed on an event. We don't care about the server, whether it's the physical server or the web server. It's now Amazon or Microsoft or Google's job to run the web server, and our job is to write the piece of code that processes the request or the event. That's why it's called function as a service, because we write the function that responds to an event. With function as a service, you can only write code that is executed by an event. You don't write something that waits, that polls, just like the web server, but it can be true as well for job queues. You don't write the code that waits for new jobs. This is not your job. You just write the function. And what's interesting as well is that you pay for the actual time of execution of your code. So here in the example of a Lambda function, this is the pricing. Let's say I have a job that takes 300 milliseconds to run. Then that's the calculation you need to do to know how much you have to pay. So this is a very small amount. I'll give you more examples in the next slides. But first, let's talk about scalability. How does it run and how does it scale? The way it runs, at least on Amazon Lambda, is that whenever there's a request, Amazon will take your code and will boot, I will say a container, like a Docker container, but it's not really a container, but whatever, it's the same thing. It will boot a container with your code inside of it, and your code will run, process the event, and then the container can die. That's it. So you get a new container when there's a new request like this. Amazon will reuse containers over time to improve performances, but every execution is pretty much stateless. If there are no requests, your code is not running. This is why you don't pay when there's no request. If there is one request, that's what you get. What happens if there are 1,000 requests at the same time, at the same exact millisecond? This happens. Your code will be booted inside 1,000 containers in parallel, and one container will handle exactly one request. And what's great with that is that that means that every execution is completely isolated from the rest. So it can run on different data centers at the other side of the planet. That's great. And that's really easy to scale because whether you have 1 or 1,000 containers, you are just limited by the number of servers that Amazon can provide. And that's their job and they are good at it. So it's basically like infinite scalability. Obviously, if those 1,000 containers hit the same database and the database has fixed resources, then the database will probably die. What you want to do if you expect scale like this is to have a serverless application end to end, so from the start to the beginning to the storage. But anyway, that's the scaling model of function as a service. Now to get back on pricing, I've taken some kind of graph of the traffic in a web application. And it's like during the night, there is no traffic. There's a small spike in the morning. Then at 9 p.m., there's the traffic spike of the day. So what you do is, if you don't do serverless, is that you take a server or several servers to handle the big spike, right? Or maybe twice that or 3 times that. But you will pay for a server that is extremely well proportioned at 9 p.m. At 9 p.m., everything is great. You pay exactly what you should be paying for. But every other time of the day, you pay a server that is much more powerful than what you actually need. So this is theoretical, but with serverless, you pay for what you use. So you pay something that is proportional to the green area here. So to sum up, in your application, in your production graph, if you use serverless, you pay for something that is proportional to the green area. If you don't do serverless, you pay for something that is proportional to the green area plus the blue area. So the more blue you have, the more you pay for resources you don't use. The more blue you have, the more money you are wasting. And the more blue you have, the more you could save by moving to serverless. Now, it depends on the graph, and obviously the compute time of serverless is more expensive than the one of a bare server, because it's a higher level service. But in some applications that can be quite interesting. There are also some applications where you have a lot of blue. Let's say, for example, a batch process that runs every night on its own server because it's really important. There you have a lot of blue, you can save a lot of money. With cron jobs, with job queues as well, it can be interesting. So again, those are the theoretical advantages. You manage less, obviously, because you don't manage the actual servers running under the application. You don't manage the Linux OS, and you don't have to patch it whenever there's a big security flow that is released. You don't manage the web server either. You don't manage scalability. You can scale more easily, and you pay for what you actually use. Now you have, I've mentioned Amazon Lambda. This is Amazon's fast offer. They were the first to start it. You have IBM OpenWhisk, which actually uses Docker containers. So that's interesting because you can run PHP quite easily. Amazon does not support PHP out of the box on Amazon Lambda. You have Microsoft Azure Functions, which has some support for PHP, and Google Cloud Functions. There are many other providers for function as a service. But if you want to start, if you want to try out things, I really recommend Amazon because they are the leading provider at the moment. They are the most stable and the most reliable ones. Now, what about PHP? So I will talk about Amazon Lambda. And as I said, there is no PHP on Amazon Lambda. Now in November last year, Amazon opened what they call the runtime API. And basically what they say is they don't want to maintain all the languages on Amazon Lambda. So instead, they open the system to other languages, and we can run PHP on Amazon Lambda since then. What you have to do is take the Linux, because the Lambda is a Linux container, so you have to take the same Linux version, you have to take the PHP sources, compile PHP for that specific version, make it as a Lambda layer, and make the correct bootstrap file so that it's correct runtime, and then upload it as a layer and use it. I mean, it's really complicated, okay? You probably don't want to do that. And that's okay, because now there is Bref, and Bref is an open source project that takes care of all of that. The idea behind that is that you get everything you need to run PHP and create serverless applications. Bref is not just about what I call the PHP runtime. It's not just about those tools. It's also about choices. Serverless is very new. There are a lot of options. There are a lot of things to choose, like choose the provider, choose the deployment tools, choose some processes. And the idea with Bref is that you get those choices they already laid out and selected for you so that you can get started more easily. Bref is also a lot of documentation because, again, serverless is new. There are so many things that are new and not always properly documented. So Bref tries to bridge the gap and provide you with all the information you need. And finally, as I said, Bref is code as well. Bref compiles PHP for you and provides you with all the tools you need. It provides also as well some PHP libraries to handle some specific stuff. And we're working on Laravel and Symfony documentation or sometimes integration so that it's as simple as possible to run those frameworks on Lambda. Now, to be more specific about the runtimes and how PHP can run on Lambda, there are actually 3 ways to run PHP on Lambda with Bref. And I will detail them. The first one is a PHP function. You can create HTTP application and console applications. So the first one, PHP function. This is exactly the same thing with Python and JavaScript. This is a function that takes an event and returns a response or a result. With that, you can run PHP just like with any other language. Same thing, and you can do whatever you can with Python and JavaScript. This is great. This is great for maybe more advanced stuff, but I guess you don't really see the point of that. So that's why there's the HTTP runtime. with the HTTP runtime, which runs with PHP FPM, you can take your HTTP application, like the Symfony or Laravel or Slim or whatever you want, and run it on Lambda, just like if it was set up with Nginx and PHP FPM or Apache and PHP FPM. Thanks to PHP FPM, you get the same thing as you get on another server. And that works quite well. There are still a few things to be aware of, but it's documented, and most of the execution environment is pretty familiar. So that's really great. And finally, you have the console runtime, which lets you run Symfony console or Laravel Artisan or any other kind of not binary, but a PHP script in a Lambda. Let's take, I don't know if you can read it, maybe that's not big enough, but it's a Symfony console to run a doctrine query. And you can take the same command and run it with Bref in a Lambda, in production or in staging or whatever you want. And that's a good way to run, for example, doctrine migrations or to debug production with a few commands or any kind of maintenance you want to do. Because given the execution model, there is no SSH access in Lambda. You cannot connect to a Lambda and do whatever you want. It can be not running, it can be running in 1,000 containers, so you can't access the production. That's how you can run commands in production. So this is what you can do with PHP on Lambda. The way you deploy and configure the application you deploy is with SAM. SAM is the official tool from Amazon to create serverless applications. So that's the GitHub repository here. And Bref documents how to use SAM with PHP. Basically, there isn't much specific, but the way you configure your application is with a YAML file, which isn't always obvious at first look, but anyway, if you use CloudFormation, that's basically CloudFormation simplified. So it's not always a good news, but anyway, it works. You have a YAML file, and you will define your functions. So those are your lambdas. You can have one, and you can have 20 if you want. You can have as many as you want. You can define here as well databases, S3 buckets, or anything you need in your application up there. And here is a function, so that's the function name, which is my function. This is the handler, so index.php will be called. This is what is called whenever there's an event. And here I configure to use the Bref runtime to run PHP. So anyway, the details do not really matter. There's documentation online, but I just want to show you that you can configure the application with YAML. And the way you deploy then is with the command line. So you install your composer dependencies, obviously, and then you run SAM package and SAM deploy. And that's how you deploy your application into Amazon. Why are there two commands? It should be one, but anyway, that's how it is. It's okay. So that's how you deploy. Now I want to go back to performances because I'm sure that when I mentioned that whenever there's a request, there's a container that boots, you're thinking about performances, and that's correct. That's a very good point. What about performances? So what I did is I measured first the response time of an application that is running, that is warm, where the application has been called a few times. So that's the production response times for a warm application. And I measured 3 execution time for an empty application. It's just hello world. So it should be 0 milliseconds, basically, because it doesn't do anything. And I measured a PHP function with the Lambda style that I showed, an HTTP application, so this is just an index.php with echo hello world, and a empty Symfony application with the hello world response. And this is what I get as response time. It's not 0, right? But this is the size of the memory allocated to the Lambda. And with the default Lambda, that's some usual mistake. With the default Lambda, which is the smallest one, you only get that much memory. This is really not much, and the CPU performance is proportional to the amount of memory. So you definitely don't want to use those kind of Lambdas, except if you have very non-important jobs. If you use more powerful Lambdas, then you have much better numbers, much better performances. We actually did a release last week, and this is now 1 millisecond here, and maybe 3 or so. So anyway, those are good numbers. Those are good enough numbers to write APIs and write websites with it, because that's the overhead of the whole stack. Now that's the overhead of the stack when the application is warm. The thing is that on Amazon Lambda, when a request comes in, a container is booted, and the probability that the container is reused over time is 1. I mean, the container is reused for 5, 10 minutes, 20 minutes, and after around 45 minutes, you have a good chance, if the container doesn't receive any requests, so on a application that receives traffic, that's fine. But if you don't receive always traffic, after 45 minutes, your containers will be shut down if they are not used. After 1 hour, you can be sure that the container is shut down. So on the next request, a container has to start up. And that's what we call a cold start. And it's around 200 and 300 milliseconds. So that's a comparison between languages. And you can see that the language doesn't really matter, as it's mostly the time to boot the container. So Python Node, it's 200 milliseconds, and with PHP, it's around 300 milliseconds. It can be 200 milliseconds sometimes, it can be 400 milliseconds sometimes. So this is important because you have to be able to accept that in your application. And it doesn't fit all use cases. But I bet that for 80% of all PHP applications running out there, it's acceptable. You get good scalability, you get less things to manage, you get okay performances when the application is warm. Having 1% of the request with 300 milliseconds added for all that you gain, sometimes it's worth it. This is the CPU performance. I mentioned it, but basically anytime you double the amount of memory, you have twice the amount of CPU power. I don't know how to say that, but anyway, you get it. This is the PHP bench, the bench.php file that is in the PHP repository. It's really CPU intensive, and I ran it, and you can see that I get good results around here. I ran it on 2 pretty powerful machines, like desktop machines, and you get around 0.8, 0.6 seconds. So those lambdas are really powerful, it seems. So that's great. Anyway, that's all great, but what about, how mature is it? Should we take our applications and run them straight away on Lambda? It depends. It depends, of course, of what you have as constraints on performances and on many other things. But it depends also on the maturity of each use case. So what I did is I built a maturity matrix. And it goes basically like this. You have 3 axes: the simplicity to use, the performances, and the reliability, like the confidence we have to run that in production. And I have several use cases. The first one are jobs and cron. And for those kind of use cases, Amazon Lambda is absolutely perfect. It's really great because you don't have to manage workers and manage servers to run all your workers and scale them. And you just write your code, and Amazon will take care of booting them and running them. It's still not as simple as I would like it to be. What I would like is to be able to run Laravel queues and maybe Symfony Messenger workers straight on AWS Lambda without any messing around. And that is planned, something to improve, but it's definitely doable. I have done it, so other people have done it, so that's a good use case. For APIs, it's really great. There is one thing to consider though. Performances are good, but you have to be able to accept a cold start. If you aren't ready to accept that for an API, like a real-time API that's where every millisecond matters, then maybe that's not the right fit. But if you have any kind of API where 200 milliseconds sometimes can be acceptable, and you can actually keep containers warm by pinging them, so you can actually get rid of the cold starts, that's okay. API is great, but if you have an API that uses MySQL or PostgreSQL, then that's not as great. You get very terrible performances because of an implementation detail on how those things run on AWS. Um, to make it short, they run in a virtual private cloud, and they have to do a bunch of stuff when the container boots, and you get sometimes 5 seconds cold start. 5 seconds. So this is really not okay for an API. Fortunately, they are working on improving that as we speak. They tweet regularly about it. So this will be fixed maybe in a few weeks, maybe in a few months, who knows. But still, that's a use case for now to hold off maybe. In a few months, maybe that will be solved, and that will get interesting. Simplicity, that's something I'm working on right now. It's documenting how to use the database and how to configure it properly. So that should be green someday in the future. And reliability, there's still something we need to document and properly benchmark is how connection are handled, like the connection pooling and stuff like this. If you have a small application, that should be very fine. If you have a large application, you need a bit of expertise on how MySQL connection works if you want to be confident. Same with websites, just like APIs. Just one thing is the simplicity is not as simple as an API because you have to deal with assets. With this execution model, you don't want to have PHP serve assets like CSS and JavaScript. You want to use maybe S3 and use a CDN like CloudFront. So again, this is I'm working on documentation here. I'm working on some tooling to make it easier. It's definitely doable. I've done my blog with that, so it's really not a huge deal, but still it could be simpler. And again, if you use MySQL, you have to expect those terrible cold starts. I've put it in orange because 5 seconds cold start in a website, sometimes that's acceptable. So it's up to you. You know, we have websites sometimes that's like 10 seconds cold start and 10 seconds response time on admin panels and legacy applications. So depending on your use case, that can be fine. And finally, legacy applications, that's the big unknown. That's you should probably wait and do simpler stuff first, because you know legacy, it's always surprises everywhere. So yeah, be careful. So there's still some work to do, but we know where to go. And to finish, I would like to show you a few case studies because that's the theory. But Bref is actually used in production, and it's actually usable right now. If you have a good use case, again, choose your use case. And so those are a few examples, small ones, bigger ones. The first one is a small one. Is the first thing I did with Amazon Lambda. It was maybe 2 years ago. I wanted to create a website which is called Return True to Win, where you have a piece of PHP code and you have to make it return true. So you have to pass a parameter here so that the function will evaluate to true. So that's a bit of a game for us, PHP developers. And the thing is that I didn't want to run that on my server because then I would do eval of whatever's coming from the internet, and that's really not something I want to do. And I didn't want to deal with the servers and stuff, so I said, okay, I'll try Amazon Lambda, where each execution can crash the Lambda, that's fine. So I have 2 Lambdas here. I have the website, which is a slim application, I think, and some twig, and that's a really simple website. And I have a Lambda that runs the PHP code. If the Lambda crashes, then the website says, hey, there was an error, just don't do anything stupid. And results are stored in DynamoDB. Anyway, I launched the website, and this is for the first month. It got shared on Twitter and Reddit and whatever, and it got a bit of traffic. And it was really great to see the website run smoothly by itself. I didn't have anything to do with scaling. I didn't have to check whether the website was done, whether the memory of the CPU was used, or if it was lacking performances. It was just running by itself. Pretty great. I was still wondering about the price. How much would that cost me? So this is for 1 month. At the end of the month, I paid for all of that only $3. So I was pretty happy, pretty relieved. and pretty intrigued as well, because pretty cheap for that. The website has been running since then for 2 years, and it's cost me 0 now, so that's pretty great. At the time, I was working on another project called PrettyCI, which is a SaaS, an application that runs code standards like PHP Code Sniffer or PHP CS Fixer in the cloud. So you can go and subscribe, and it will run the tools to check the coding formatting every time you push a commit to GitHub. And I started doing that application with Laravel. I was discovering Laravel at the time. I deployed it on a DigitalOcean server, really small one, and I set up some workers so that whenever you push to GitHub, I receive a webhook, I put that in a queue, and I have workers that process the commits. But I was worried that I had like 3 or 4 workers because it was a really small machine. And I was worried that over time, I would have to scale that either by paying a more expensive server or adding more servers and dealing with all of that. I thought, why not run the jobs on Lambda? So that's what I did. And now this is what I see quite often. I push a commit, and unless you have something very weird or specific going on, most of the builds take less than 5 seconds, from the time you push to the time you have the commit status on GitHub. So you can open the pull request, and it's already green. While it's still pending, it's not even running. It's still pending on Travis or AppVeyor or CircleCI. So that's really great for users, because they never have to wait. The job is running instantaneously. As soon as there's a job in the job queue, a container will be booted and to process that job. I don't have to scale anything, it's done for me. It's good for users, they don't have to wait. It's good for me, I don't have to scale anything. I pay only for a few executions over there, here and here, so it's a really good deal. That's why I highly recommend Amazon Lambda for jobs. Another case study about jobs is Enoptea. Enoptea is a French startup, and what they do is they process a lot of energy bills. So they process some PDF and parse data from that and aggregate it and create reports and statistics. And so they have a lot of background jobs. They don't have much web traffic, but they have a lot of background jobs. So the numbers, they date back from a year ago, about a year ago. And at the time, they were growing. They still are, but they were growing, and they started by implementing all their system with PHP, with job queues on EC2. And it was working fine, but eventually they started to have an Amazon bill that was more and more expensive every month. They had to deal with scaling, and they had trouble scaling sometimes. So what they did, they started doing that in July. They started moving from EC2 to Amazon Lambda using Bref. And this is what happened to their Amazon bill. So it was increasing, and then it started moving to Amazon Lambda, and their bill started decreasing every month. I don't have the final numbers for the end of the migration, but they were expecting to halve or even divide by 3 their Amazon bill. So they were pretty happy. I don't have the total numbers here, but I do have a number for a specific microservice that they completely migrated to Amazon Lambda, and they went from $800 per month to $90 per month. So for them, it was quite a success. They saved money, obviously, but for a startup, what's even more important for them is that they were not afraid of scaling anymore. They could scale, they could sign a big client without having to worry about how much servers they were going to need and how to deal with all of that. So they are still running it, and they are pretty happy with it. So that's a good story. And the last one is Sua Musica. I don't know how to say it properly. It's a Brazilian website. And so the information here was shared on the GitHub repository by a Bref user. So they started working on this website and running it on Amazon ECS, so containers running on EC2. And they moved all of that to Amazon Lambda using a custom PHP runtime, and now they are moving to Bref because they don't want to maintain their own PHP stack. The way the website runs is with an API in PHP and a website in PHP. That's the average response time. So as you can see, they use MySQL as well. So as you can see, they are pretty happy with the response time. That's a fairly normal response time for them. Good performances. They use Falcon, so that's something they have to compile. But anyway, they use Falcon. They're happy with it. They use MySQL, so they do have to deal with the cold start I mentioned. But from what they've said, to them it's not that big of a deal because they don't see them often because the website is always running and always warm. It turns out they have a lot of traffic. They have 40 million requests per day. And everything runs on Lambda and MySQL. At peak time, they have more than 2,000 concurrent executions of Lambdas. So more than 2,000 containers, or they are called micro VM, but whatever. That's a lot. There's a soft limit at AWS, which is 1,000. So if you want to get over 1,000, the 1,000 limits, you have to ask the support. So this is a very good use case to understand how websites can run on Lambda. And their migration from ECS to Lambda saved them about 25% on their bill. So they saved money moving there. So to conclude, what should we do? Should we go ahead and migrate everything to Lambda? And there's the question, obviously, of is serverless mature? So I've talked about the maturity matrix. Serverless technologies are mature. Like Amazon Lambda is mature, definitely. It's been there since 2014, and it's used by very big companies to handle very high loads and do very important stuff. So no worries with Amazon Lambda. However, as you've seen in the matrix, there is not enough maturity everywhere, especially in the documentation, in practices, in our experience. I mean, we don't really all know how to run those new those applications on serverless. So this is new. But this is fine. We just have to learn. We have to experiment. We have to improve our collective experience. We have to share. I think this is worth it. Because from what I've seen, yes, you can save some money. But you can, what I find really interesting is the way you can empower parts of some people in the team or parts of teams to create their application without having to ask for a server, without having to worry about having a DevOps person or sysadmin in their team to manage everything. You can just say deploy your application. It will cost nothing until it's in production. You can iterate very easily, and you can integrate with a lot of services. So there's a lot of potential here, and I think it's really worth discovering all of that and sharing about it. Thank you.